1, 2, 3. What's up, AV industry? Welcome back to the channel. My name is Slava Nesmianov. Every day AV systems got more complicated and way easier to break. New features, more protocols, more way for things to glitch. And if you think it's bad, the numbers say it's only going downhill. Right now, around 30% of working hours are wasted fixing something. And over 75% of diagnostic mistakes aren't about busted gear. They're about busted thinking. People chase ghosts, they panic or jump to wrong conclusions. But here's the good news. Use the right strategies and right thinking, and you can fix problems twice as fast. So today we're talking about real troubleshooting. I picked my best field-tested tricks that turn chaos into signal. And by the end of this video, you'll get methods that actually work. So please hit that like button, smash subscribe, and let's turn you into a real troubleshooter. Unlike most troubleshooting guides, I'm not just going to list a bunch of strategies. We'll start with something most people skip: when to use each approach and how to choose what actually works for your setup. We will talk about the right mindset because thinking straight is more useful than any checklist. You probably noticed that most problems come from hurrying, and we're so eager to find and fix the issue fast that we get confused. And sometimes panic makes things even worse and you don't know where to start. That's why you need the rule number 1. Start broad and go narrow. This is absolutely vital. In general, every troubleshooting process follows this logic. Step number 1, we go as broad as we can, verifying the problem is real. Here you make sure you're not chasing a fake issue, and that alone knocks out a lot of possible causes. Step number 2, defining the boundaries. Here you figure out which part of the system is actually affected. It gives you a lot of information. Instead of guessing everywhere, you focus only on the area where the problem shows up. And step number 3, isolating the variables. During this process you go even more narrow, you check each part of the affected area, and that lets you spot exactly what's causing the problem. As you can see, step by step you cut down from "it can be almost anything" to "it's probably this one." First of all, it keeps you from chasing ghosts. Let's take a real quick example. The client says there is no audio in the room, and your instinct might be to start touch faders or dive into the DSP software or start swapping cables. But instead, you should probably begin with step number 1 and verify the problem exists. Maybe they just don't play out the song, or the speaker is disconnected. Check the basics. You'd be surprised how many failures end right there. But if the obvious stuff didn't save the situation and you still have no audio, congratulations, you've got a real problem, and that's where probably the real troubleshooting starts. And again, you start broad and go narrow. And that means answering, is the problem everywhere or just in one particular spot? Is it one room? Is it one part of the system, one device, or maybe one connection? You narrow it down instead of random guessing. Find the scope where the problem appears, and when you got exact symptoms, you're ready for the step 3. This is blessed moment when you actually fix things. Here's the detective work. You already defined the boundaries and you know a particular chain that works wrong way. And now you're looking for whose fault it is. You know, at the end of the day, all we do in AV is technically push signals from the source to destinations and hope they survive the trip. So you send the signal, you follow it and see where it flows and where it dies. You can test at each handoff, feed test signals into different parts of the chain. Can you get the signal at the end? Then the fault's before that point. If not, it's downstream. So do not jump randomly. Start at the system level, narrow it down to the module, then to the source, then to the input. This way you're not gambling, you're proving. Step 3 is probably the most skill demanding and exciting part of the troubleshooting. And that's probably why we always try to jump straight to this part. Okay, once the general 3-step structure is clear, let's look at the specific strategies you can use to make the 3rd step even more effective. The very first strategy is called the known good swap. It's a classic test, so basic it hurts, and yet people still butcher it daily. So here's the trick. You do not go swapping everything like a mad scientist. Instead, you isolate the problem like an adult. Start at the source or destination and follow the signal, checking every component along the way. And for the God's sake, swap just one thing at a time. A known good cable, or a known good transmitter, a known good input. If the problem disappears, congratulations, you found your culprit. But if not, you keep going down the chain, isolating your problem. Sounds obvious, but everyone loves cutting corners till they're crying on the floor with HDMI cables tossed around. A known good swap is simple and logical approach, but it takes time, especially in a big sophisticated systems. So there's a faster way you can use to optimize a search, and it's called divide and conquer. Divide and conquer says if your signal chain's too long, you cut it in 2 equal parts, and now you've got half the hassle, cause the glitch is hiding in just one chunk anyway. So all you gotta do is sniff out which side's guilty, keep splitting faulty side till the issue taps out, and each check cuts your problem space in half. That's the most efficient way. The key here is having some test gear on hand. You can use smart routing and quick bypasses to check your setup. For example, send the video straight to a monitor or feed the pink noise into the input. And what I love about this approach is how universal it is. It works for just about anything. Audio, video, networks, circuits, even code. Split, test and repeat until the faults got nowhere left to hide. Alright, when we found the suspect, it's time to see if it's really the one. And this is where the loopback testing can be useful. Loopback is a quick way to check if your gear or connection actually works. You send a signal out and you wait for it to come back to the same point. For example, we use loopback to calibrate audio chains, verify a piece of gear is running or measure latency. Grab a short patch cable and physically connect the device's output right back to its input. You're literally creating a loop for the signal. You send out the test tone or video pattern, and if it gets back clean, you know the ports, the processing and the routing working fine. And the second option is internal loopback. It's even slicker because no cables needed. The device routes the signal internally from its transmit side straight over to its receive side. It sends out a beep or test frame, listens for the echo and checks if what comes back matches what went out. Either way, the logic the same. Signal goes out and signal comes back. If they match, you're fine. When AV moves to the network, finding problems gets tricky. IP video protocols isn't always a straight shot like a signal chain, and that's why I'd like to make another video about IP-related troubleshooting. Network can follow different topologies, unlike classic SDI setups where one signal runs through one cable. Sometimes all your gear relies on a single LAN cable, so labeling wires and other best practices you used before probably won't save you. The world is changing and your troubleshooting tools need to keep up. If you're using NDI or SIMT ST2110, first you should be able to ping your gear around. Remember, define the boundaries. If your gear doesn't answer, you've got a place to look. Trace route option can help you to find where the signal hits a wall, and if it drops 2 or 3 hops from the endpoint, you know where to dig for a problem. Wireshark software is your friend for seeing traffic and spotting if things freeze. You don't have to be a network wizard, but it's worth to know if your data is moving or stalled. So here's the big takeaway. Troubleshooting isn't a guesswork. It's an investigation built on data, structure and smart repetition. If you want to be the tech who walks in, fixes it and makes it look easy, subscribe to this channel. Hit the like and please share the video with your team, because let's face it, in AV we are all just one bad cable away from madness. My name is Slaven Smiyanov, thanks for watching and see you in the next one. Bye.